This time on Jairus of All, I take some things that I've either spent a huge amount of effort or money on, and I cut them up into pieces. I'm gonna start with a big thank you to all my Patreon supporters who made this Buster Sword build possible. If it wasn't for them, there's no way I could have done this build. Link in the description if you want to be part of that amazing group of people. Now on to the build. Do you remember at the end of the first build video for this thing where I was like, oh, it's gonna take a bunch of time, I'll hand sand this back and then it'll be ready for me to put the carbon fiber on it? Well, I was wrong. It was a lot more work than I thought. But these steps were extremely important. Because I don't have a mold for this and I'm just using a core, I need to have the core be perfect because that's the only way the carbon fiber will come out the way it's supposed to. It's just going to be vacuum bagged and squished onto it. Because I'm putting 5 layers of carbon fiber around it at least, that might be enough to hide problems, but there were soft spots and big holes in the foam and I had to get rid of them. So I decided that the best course of action would be to take some fiberglass, just 1 layer on each side, and cover it to make a nice, tight, resilient surface for the carbon fiber to go on. After the fiberglass was on and it was almost set up, I trimmed the edges with scissors, the scissors that my Patreon patrons got me, and then I waited for it to cure. Which, according to the container, was supposed to be 2 hours, but that did not happen at all. It took 2 days. You might be thinking, well, that's because it was probably too cold. And it was kind of cold in here. But I made a tent around this with a piece of plastic and blew a hairdryer into it so that it warmed it up. And I had this thing really hot for a really long time and it still didn't cure. I knew I couldn't waste any more time waiting for this to cure, so I wet sanded it because if I tried to sand it while it was still gooey, it just clogged the sandpaper. I knew there were some areas that were uneven, but I didn't realize how bad it was. Gave it a coat of primer so that I could really see the imperfections on the surface, and that's when I realized that it wasn't flat at all, and I was gonna have to do a bunch of filling anyway. During that wet sanding process though, some of the water went through the fiberglass because it wasn't completely saturated because I was trying to keep the weight down, and the foam absorbed some of the water, so it took like 12 hours to dry it out after that, before I could start putting the wood filler on, and that took many layers, skimming it and sanding it over and over again on both sides until it was all dry and nice and level and even. But now it's perfectly flat and exactly the way that it should be. And it's ultra straight too. Very straight. Now that was a lot of work, and it was all because I didn't get the proper core material that people usually use when they do composite setups like this, where they're using the core as the mold. But I couldn't afford those core materials because they are rather expensive. So polyiso insulation board it was, unfortunately. But this is now ready to be prepared to accept the carbon fiber and titanium. Doing composite work is like painting a car. Lots of prep work. Everybody wants to put the cool stuff on and spray the paint, but that's not where you get a good product from. It's from all the prep work beforehand to make sure that it's going to work out. I haven't done fiberglass for a long time, and I've only done carbon fiber 1 time before, so we'll see how this goes. But first, look at how outrageously huge this thing is. But honestly, after playing with this thing for so long, it doesn't even seem like it's that big to me anymore, if I'm honest. It seems like this is normal sword size. I've spent a lot of time with it. Currently, the core is at 21.86 ounces. 620 grams, 619 grams. And the titanium before beveling, 16.57, and 470 grams. This is what's going on at the cutting edge of this thing. The blade edge here is going to penetrate the watermelon here. In doing so, it receives force this direction, and as it's traveling through, it is being squished by the melon from the sides like that. You have the actual sharpening angle of the blade, and then you have the bevel angle. Chef knives can get sharpened down to 17 degrees, but that's 17 degrees per side. Overall, 34 degrees for the blade angle. But then that is a very small portion because the bevel angle of the knife is far shallower. But the part that is sharpened is very small, and then the bevel angle behind it is the vast majority of the knife. This sword, on the other hand, is over 1 inch thick. Its bevel angle the whole way back is 17 degrees total, which means if I maintain that, I would have to sharpen the titanium down to 8.5 degrees for the cutting edge. Obviously, I'm not going to do that because that's not what they do on kitchen knives. They taper slowly, and then right at the edge, they are sharpened. But this presents a problem for me, and it'll be very apparent when I draw this to scale, times 10. My piece of titanium is going to sit inside of the blade bevel like this, and my cutting edge will be here. Now, if I were to sharpen it the whole way back, I would only have this much of the titanium mounted inside, which would be approximately 0.33 inches or 8.4 millimeters, which is not very much to support a piece of titanium inside a very thin layer of carbon fiber. But the issue is that that is where the fiberglass is holding it currently. It's not holding it currently because it's not in there yet, which is what we're getting to. According to an online calculator with 5 layers of the types of carbon fiber that I have, my exterior wall thickness will be 0.06 inches thick. And if you're a metric person, you can just do the conversion because everything over here is in SAE, is in inches. So, sorry. If I lay the carbon fiber on, I have a huge amount of traction on the piece of titanium if I leave it straight the whole way down. Problem is, if I do that, I am only left with a tiny bit of titanium to sharpen for the actual cutting edge, which gives me a sharpening angle of approximately 45 degrees. Overall, blade sharpness of 90 degrees, which is completely unacceptable. But I do need to have a plan for the force that's coming into the front edge of the blade to make sure it doesn't just pop it out. Bond strength between carbon fiber and smooth titanium is not very much. Carbon fiber does have very high tensile strength though. My initial idea was to sharpen titanium, and then after sharpening I would base how far back into the foam I set the material so that the fiberglass met up at a certain point, and then my 5 layers of carbon fiber would come down along the side of the titanium, and then it would get ground back so that it wouldn't catch whenever I tried to cut stuff with it. This still affords me not much traction there, but I figured I would just cut little grooves into the titanium, and that would give me a mechanical bond between the two materials. But that didn't seem like it would be enough, so I came up with a new idea where the fiberglass would be trimmed back behind where the titanium sat, and the first 2 layers of carbon fiber would come in around and bend behind the blade. And I could do that with 2 layers back and forth. That would give me strength to hold the blade forward, the titanium forward. And then the last 3 layers would come down and hold the blade on the side. Problem with that is that it would give me a big dip right here once it's vacuum bagged. I need to take some of that fiberglass and foam that I trimmed out and put that inside of there. The difficult and probably impossible part of this is it seems like it's a good idea when you draw it out this big, but when you're talking about what kind of bend radius you're getting, people said you shouldn't do less than 1 to 3 millimeters. We're talking about a bend radius of about 0.5 millimeter, which is like that. So that would be almost impossible to do, and it would probably break those carbon fibers almost immediately, and I wouldn't be relying on tensile strength. I would be relying on the layer adhesion because it would push this backwards. So new plan, more complicated, but should be much easier to pull off. In this picture, this is where the titanium is meant to be set to have an accurate dimension from the front cutting edge of the blade the whole way to the back of the sword. So, working from this, I have a solution. Because I can't bring the carbon this far out, I need to do something to reduce the area in which it contacts the blade. But I still need that reinforcement behind. So the new idea is the titanium will be rounded off at the back. Because of its thickness, I am able to meet the minimum bend radius for carbon fiber. Then the front of the blade will maintain a 17-degree sharpening angle, which allows me overall blade angle of 34 degrees, just like it is on a chef's knife. The bevel will stay at 17 degrees overall, but in order to support the titanium with a smaller amount of contact area, there will be a taco around the blade of carbon fiber, and then the entire bevel will be cut off and reinforced with carbon fiber here and up through the center with 2 layers that will wrap around the taco, 1 on each side. This will give me support from the backside because I'm basically creating an I-beam behind my titanium blade insert thingy. The problem with this is the carbon fiber will go beyond where the blade angle is at the cutting edge. So in order to mitigate that and have as much contact between the carbon fiber and the taco that's around the titanium, which will be holding it in tension, which is where carbon fiber is strongest. The fiberglass will be cut slightly further forward from the blade edge and then tapered in so that the carbon fiber, the 5 layers coming up the sides, are able to come up and wrap into the taco and support it, and then I can just sand them off back to that 17-degree angle, and that gives me approximately 0.6 the whole way down. And all I have to do is take the measurement of 0.6 here and come down and follow that radius in, and then 0.6 away from the blade. Basically, wherever that should contact the blade to give me the entirety of 0.6 being in contact with a piece of titanium is where I would cut fiberglass off, begin that small radius, split this piece of foam in half for the entire bevel, and do some initial carbon fiber work. But the big problem with all of this plan right now is I don't know if I have enough carbon fiber to do all this stuff. So I guess I need to cut out some carbon fiber. I am so excited about this part. I hope you like this pattern as much as I do. This is going to be the pattern on the outside. I've seen this stuff called 3 different names: wasp weave, honeycomb, and hexagonal pattern. Basically just 3K carbon fiber with hexagons stitched into it with extra toes. So this is slightly heavier than normal 3K carbon would be. This is Fiber Tech. You can squirt this on the fabric to cut it, and it keeps the fibers bound together, and then it dissolves in the epoxy resin that you use when you sand up. It makes it easier to cut, doesn't affect it, and it dries out, so it won't be sticky for good. And you can also use this to get stuff to stick to your mold. Read the directions. Spray a mist of MT1 towards intended application area. Blah, blah, blah. Okay. I'll just have to keep it folded in so it doesn't stick to the plastic. All it takes is a light coat, apparently, for this to hold your fabric together. I can't let the plastic on it right now though. It takes 3 minutes to dry. I'm gonna cut this a little oversized, give myself some space. I can always trim it back later, but I can't add to it. These scissors work awesome. This cuts carbon fiber way better than I thought it would. Ooh, almost knocked you down. Bottom here I'm not as worried about. This goes to bottom of the sword blade, but this bottom of the sword blade is actually going to be inside of the guard. So this is not nearly as critical because you're not going to be able to see any of this at all. That fiber tack holds these fibers together really nicely. It's not getting messed up at all while I'm cutting it. I am kind of worried about the pattern at the distal taper though. The spine of the sword comes down. Like the bevel is the same angle the whole way around the whole sword. The reason it gets smaller at the tip is because it's distal tapered out there. And it actually gets a little smaller on the main part of the blade too. There's 1. 4 more. Problem with this 2x2 drill, you're supposed to, if you really want it to be good, alternate the direction of the layers. This way and this way is one layer, you know, the threads go that way. The next one you turn 45 degrees, gives you more strength. Problem is, I don't know if the piece that I've got is big enough to do that. And this stuff is way looser than the hexagon stuff. So the issue is the sword is 54 inches long and this cloth is 50 inches wide. If it was 4 inches shorter, I could do them all this way or I could do them sideways. Oh, that was dumb. I need the template. But since I can't do that, I need to do at least 2 of them straight right there. I'll lay this out and see if I can do it here, which at this point it looks like I will not be able to. The only way I'm gonna get this all on this material is if I stagger the ends. Center point to center point. Ooh, it's gonna be close. See how loose this is? Good thing it's all getting hidden. This isn't looser than carbon fiber normally is. It's just You forget how easy this stuff slides around on itself. I might have to fiber tack this. I'm gonna fiber tack this. It's just way too soft. And that fiber tack did a really nice job. If I could stop catching my gloves on it, that would be awesome. I think I can make all 4 fit. Carbon fiber to be able to do my plan. Now I gotta mark where this thing's gonna get all chopped apart at. Pen or pencil. My kingdom for a pen or a pencil. There we go. All right. Bevel is there to 1/6 is where this gets cut off. 1/6 of an inch. And then at the bevel. Okay. This thing 1/3. It's half of 1/3. That's not my mark. That's my mark. Goodness. Alright, let's try this again. I need more hands. I'm using the piece of titanium instead of a ruler because there is the slightest curve in it, but it looks like there is the slightest curve in the actual Buster Sword. I can't tell. It's really difficult to tell. I mean, a lot of people say that it's straight, but in a lot of the pictures, it looks like there is a slight curve to it. But it would make this measurement off. I'm gonna use a ruler for this one though, because I can't hold that side up while I do it. It's always a strange feeling when you take this much time to make something really perfect, and then you just chop it into pieces. See, that doesn't, is that line on? Nope. It needs to be further. So if the blade sits inside of there, but this is cut off here. Let's see if you can see this. It's supposed to go approximately across there. You can see how the line intersects. What does that mean? It just won't be able to be wrapped backwards once it gets to this point, right? Yeah, because that's going to be crazy down there. But it's the very tip. I'm not that worried about it. I do need to get my measurements for the bevel though. See how accurate. Man, I was dead on here. Yeah, see, that's not right. Unless I drew that line wrong. Did I look at the wrong number?
No, you got the wrong number.
I looked at the wrong number. I'm an idiot. That's where I want to be. Yep. Perfect. This cutting disc is 0.03, so it's the perfect thickness for the material that will be coming through the crack, and it'll keep my dimensions the same. Not that 0.03 is that much of an inch anyway. I lost the strap to these, so I put electrical tape on them. It works, but it's a pain in the butt to install them on my head. My sword shrank. The easy task of just splitting this exactly down the middle. I'm gonna sand the track out for the titanium first. Then I gotta split it down the middle. Titanium is 0.13. This is 0.15. Enough room for the wrap. This is working out perfect. The fiberglass is holding the sandpaper in. I'm gonna get perfect groove for this. Just gotta make sure I don't go too deep. Perfect. Tape guide. What am I catching on? Right there. Yes. It's sitting higher because this made a rounded groove, and this is square currently, but I am going to round over the back of it so that the carbon fiber has radius to cup around it, not sharp edges. And this thing sat right down in it. Everything's going well so far. Fits back together perfectly. The teeth on most saws go back and forth. They will. That way you cut away a certain amount of material, that way the blade doesn't get bound up. But I'm cutting foam, that doesn't matter, and this blade is the perfect thickness for the layers of carbon fiber that are gonna go in there. So I ground off the things. Now I can cut out the right amount of material and split the bevel in half. Here we go. 2 pieces. A little bit of mess ups here and there, but that'll work. Nothing left to do but get this thing ready. Sharpened and rounded. This took over 8 hours to grind the edge down for the cutting edge and put these grooves in so that it mechanically adheres to the taco of carbon that goes around it. All of that titanium grinding netted a bunch of titanium dust, which is awesome stuff. Check this out. With everything that was more difficult than I thought, and me complicating the process more than I had planned on it being, it's a physical impossibility for me to be able to get the carbon fiber on the sword before this video has to go out, which is about 24 hours, which means you get a bonus. I know you really want to see this thing covered in carbon fiber, so I will be doing a live stream. So make sure you have notifications turned on and subscribe, because I can't tell you when that's going to be, because it's whenever it's done. I'll do a live stream of me peeling it out of its vacuum bagging materials, and you'll get to see it for the first time with me. So there's a lot of prep work that needs to be done before I get to the point where I can even start laying that up. And I don't want to screw this up because there's hundreds of dollars in this project. My vacuum system is leaking and I'm not sure from where, and I'm narrowing it down. Thanks for watching. I hope you enjoyed the video. I'll see you sometime this week and next Sunday when I try to have the sword completely finished. Yep. I think that's my outro.